Okay, everyone. Welcome to day 2 of Ignite and AI-powered automation and multi-agent orchestration in Microsoft Foundry. My name's Shawn Henry. I've got my colleagues Tina and Mark who are going to come up shortly. But let's get started. Everybody, I hope everyone's in the audience here. Make sure you got your headphones on and 3D glasses are under the chairs. No? No 3D glasses? Okay. No 3D glasses this time. I can't hear you guys laugh. Let's get started. Okay. So 2025, the year of the agent. I was up here at Ignite last year, and was telling our story about how we believe at Microsoft agents are the future. They're how we're going to get LLMs and AI models to act and reason and integrate with our existing systems. And in just the course of the year, we've seen millions of agents being deployed into Foundry. Over 25,000 organizations are building with Foundry, with AutoGen, with Semantic Kernel, with our new Microsoft Agent Framework. And they've been doing that by some of the things we're going to talk about today to help you build your agents, deploy your agents, and operate your agents in Microsoft Foundry. Today we'll look at our new unified Microsoft Agent Framework. We'll look at multi-agent workflows and some of the visual tools you can use to help you build your multi-agent systems. We'll look at deploying, managing, and evaluating your agents all in one place in Microsoft Foundry. And we'll talk about how to customize your agent systems with UI channels, getting them deployed into M365. And then we'll look at how you can monitor your agents, how you can do compliance and governance on top of your agent systems. And we've been working with these thousands of customers and a lot of partners at Microsoft over the course of this year to build multi-agent systems for scenarios like customer support and sales assistance, internal productivity, knowledge assistance, and document research. And one of the partners we've been working with closely is BMW. So I'd love to just kick this off by bringing Christof Gebhart up here, and let's take a look at what BMW's been doing. Come on up, Christof.
BMWs are built with quality and reliability that people trust.
Our engineers integrate every car with cutting-edge digital features to help keep drivers safe on the road, while delivering world-class performance. Testing of all functions plays an important role.
In the past, we used hard drives in our development cars to store test data. Developers had to wait at least a day to get fresh data for analysis. We built the mobile data recorder that's integrated into the car's digital nervous system. This IoT device transmits data in real time.
For our time series analytics, Azure Data Explorer was the only way to go.
Now, engineers can chat with the interface using natural language through Azure OpenAI service. The MDR Copilot's front-end and back-end are managed by Azure Kubernetes Service. Azure Database for Postgres stores Copilot conversations and feedback. Azure is the turbocharger for delivering the right data to the right person on a large scale.
Data analysis went from days to minutes, with speeding time to market even as the number of features increases dramatically.
MDR, powered by Microsoft Azure, ensures BMW reliability and quality long before the cars hit the road.
That was great. Was that you driving around in the snow at the beginning with the drifting? No?
No, actually, there were some colleagues.
You have some pros doing that? Okay.
Test drive, yeah.
So since that video came out, Christof, what have you been working on and what improvements have you made since then?
So the MDR ecosystem has evolved in hardware and software. On the hardware side, we've introduced a more powerful Linux-based in-vehicle device that is now part of the core vehicle architecture. This unlocks a new level of data integration. MDR is no longer just a passive data logger. It actively interacts with control units to capture maximum data. And here is where it gets exciting. These updates allowed us to move beyond democratizing data. We are democratizing data analysis. Our MDR multi-agent lets engineers ask questions and get data analysis in minutes. No more endless manual search.
So you had moved all your MDR data and you modernized it by putting on Azure. What did you see that made you decide that maybe a multi-agent system was better than a single agent system?
Well, the challenge was never data volume. Our development fleet generates more than enough data. The bottleneck was data pre-processing, turning raw, diverse data into a clean structure. Our single agent system made data access easier, but as questions grew more complex, we hit its limits. That's why we moved to a multi-agent approach. Specialized agents handle retrieval, pre-processing, and analysis. This modular approach scales easily. We can always add new agents for new data sources or analytics methods. Now engineers can ask more sophisticated questions and get faster, more accurate answers. Our teams can experiment faster and iterate quickly.
So how about you walk us through your architecture? You have an orchestrator agent that's coordinating everything. You have a data analysis agent. You have a data retrieval agent that are working together, right?
Yep. So at the center is the orchestrator agent. It manages the entire workflow. When an engineer submits a question, the orchestrator creates a plan and delegates tasks to specialized agents. Data retrieval is handled by two agents that craft queries, pull the telemetry, and retrieve the data. Once the data is in, the analysis agent takes over. It generates Python code to turn raw telemetry into actionable insights. Finally, the orchestrator compiles everything and delivers answers to the user. The Microsoft Agent Framework ties it all together. It gives us a robust open source toolkit to define, connect, and manage these agents. And the Foundry Agent Service is our cloud-based garage. It deploys, scales, and monitors agents automatically.
That's great. It's great to see Microsoft Agent Framework and Foundry Agent Service working together. We're going to talk about that a lot today. So you reported like a 10 times faster kind of iterative loop for access for your engineers. What other kind of measurable outcomes have you had, and where do you see this going next across your R&D?
We've moved from static data access to dynamic agent-driven insights. The impact of our multi-agent system is clear. Broad access to all telemetry data for all engineers, and advanced analytics at scale. Our vision is to empower every development team to build their own specialized agents to analyze all vehicle data using the knowledge of as many engineers as possible. This ecosystem of intelligent agents acts like a digital R&D companion, a proactive partner in engineering, learning, adopting, and helping engineers focus on innovation. With every new agent, we move closer to a future where automotive development is faster, smarter, and more collaborative than ever. And we are so excited to continue this journey together with Microsoft and the developer community.
Great. Thanks, Christof. If you want to find out more about what BMW is doing, we've got a QR code here. And if you want to go get in contact with Christof, there's his information. Thanks, Christof. That was great.
Thank you.
So as we worked with folks like BMW and our partners over the course of the year, we got a lot of questions from them about how to start their agentic journey, how to build these agent systems. They had questions like, where do I start? What frameworks do I use? How do I connect my agents together? How do I connect them to other services? How do I know what my agent's doing? How do I evaluate them? How do I deploy and manage my agents, get them up into the cloud? And how do I build good user interfaces on top of these agents? So I'd like to bring Mark up here next to talk about how we approach some of these challenges and some of the great new features that we have in the Microsoft Agent Framework to help you build your agentic systems. Thanks, Mark.
Okay, that's great. Okay, so yeah, thanks a lot, Shawn. So I'm going to start talking about the agent framework, right? So the first step was earlier this year, there were two teams, the Semantic Kernel team and the AutoGen team. They were merged together with the view to converging the SDKs that the teams were building. What that kind of turned into is the Microsoft Agent Framework. Microsoft Agent Framework is a new open source project that has two core capabilities. It provides the ability for you to create agents using any service. You can create your agent, you can give it a model, an LLM for reasoning, you can give it tools to take action, to retrieve additional context, and also to generate and use memories. In addition to the agent capabilities, there's also a workflow builder that allows you to create deterministic workflows. And this allows you to orchestrate multiple agents. So the combination of non-deterministic agents and a deterministic workflow is what allows you to build reliable multi-agent systems. So the Microsoft Agent Framework term has actually become an umbrella term that incorporates more than just the open source project. The open source project is a great place to go if you want to see how to use Agent Framework with lots of different technologies that are available within Microsoft and also external to Microsoft. But Agent Framework is kind of like an umbrella for all of the pro-dev agentic capabilities that are being developed inside of Microsoft. Okay, so the Microsoft Agent Framework as it currently stands has a .NET and a Python version. They're in public preview at the moment, but the team's working very hard to get them to GA. So early next year, all of this stuff will be generally available. You can use Agent Framework as a pro developer to build agents and multi-agent systems using Foundry. So it layers very nicely on top of Foundry and takes advantage of all of the capabilities you get in Foundry. All of the models, all of the tools, all of the memory capabilities. In addition, like one of the questions we get asked a lot is, where are you using Agent Framework internally within Microsoft? So Agent Framework, the workflows part of Agent Framework is part of the Foundry service. So Foundry has a new workflow capability, and that's built on top of Agent Framework. So Foundry itself is kind of customer number one for Agent Framework. In the development of Agent Framework, we've adopted open standards. So you can use MCP to retrieve additional context for your agent. You can use A2A for inter-agent communication. And you can use a protocol called AGUI. It's Agent User Interface Protocol to build your UI for your agentic application. The Agent Framework is also extensible. So you can plug in different agent services, different model providers, different memory services. The Anthropic announcement yesterday is a really good example of the extensibility of Agent Framework. Right now, if you use Agent Framework, you can use the Anthropic models to build agents. So Anthropic models deployed on Foundry, you can use those in the Agent Framework straight away. So we were able to basically add that functionality in very, very quickly. There's lots of extensibility mechanisms available, and there's lots of teams within Microsoft who are building extensions to Agent Framework. We're also encouraging third parties to build extensions as well. Okay, so another question we get asked a lot is, what if I'm using AutoGen or using Semantic Kernel? What's your recommendation? So our recommendation is that for any new development, use Agent Framework. It'll be generally available early next year. If you have existing code, we're going to be maintaining AutoGen and Semantic Kernel, like we've done recent releases. But we'll definitely want to encourage you to migrate. There's a lot of capabilities that are in Agent Framework, really interesting capabilities that aren't going to get added to the other SDKs. So migrating makes a lot of sense. To help you with your migration, we have the GitHub Copilot app modernization extensions. They're available in Visual Studio and Visual Studio Code. What they give you is a one-click migration story for your existing code. When you start the migration process, the tooling will analyze your code base and it will come up with a plan to migrate it to Agent Framework. It will then start the migration process and keep track of everything that it's doing as it's migrating your code. So you'll end up with a plan of execution. It will run all of the tests associated with your with your code base. And if there's any static analysis configured for your code base, it'll run that as well and make sure the new code is compliant. When the process completes, you'll get a summary of everything that's happened. A branch will be created. All of the code changes will be committed to that branch. Everything will be documented. What will be left for the developer to do is create a pull request, review all of the code, and then basically kind of like merge that in. This is all available right now. The extensions are available on the Visual Studio Marketplace. We're really looking forward for people to start using this and give us feedback. If there's something about your application that the tooling doesn't work well with, let us know and we can fix that. Okay, so an interesting extension that's just been announced is the durable task extensions for Microsoft Agent Framework. What this allows you to do is build durable agents and durable agent orchestrations. So with the best will in the world, something will go wrong when you've deployed your agent. A service may become unavailable, an agent may crash. What the durable task extension does is it will create checkpoints as your agent or your multi-agent orchestration runs. And then if something goes wrong, you can basically restart the agent or restart the orchestration, and it can pick up from the last checkpoint. It doesn't have to go right back to the start of the operation. It can just kind of pick up and continue on. This has some very interesting implications if you're dealing with human-in-the-loop scenarios. So for human-in-the-loop, if an agent or a workflow needs human feedback, it may take minutes, it may take hours, or it may take days for that feedback to come in. What you can do with the durable task extension is that you can spin down the compute that's running your agent or your orchestration, wait for the human response to come back, and then you can basically spin everything back up and then continue with the execution. The durable task scheduler actually handles that process. It actually comes with its own dashboard. The dashboard allows you to see in real time what's happening in your agents and what's happening in your orchestrations. So it gives you an extra perspective. You can actually kind of go back to different states, different snapshots for your agent, and actually inspect kind of like, what was going on at that particular point in time. Okay, so I'm going to just switch gear now and switch to doing a couple of demos. Okay, so. Okay, so we're going to start by looking at some code, right? This is the code to create a workflow. The workflow I'm building is for an event planning scenario, right? So there's a couple of things that I need to consider. I want to be able to select a venue for my event. I want to manage the budget. I want to manage catering, and then I want logistics coordination. So what I've done in this particular application is that I've created an agent for each aspect of the workflow. Then I have one agent that's basically the coordinator, and it's going to coordinate the execution of the entire workflow. There's all of the agents are basically wired together so that they can talk to the coordinator. Now, one of the things that we're providing in Agent Framework is a tool called the Dev UI. So when I run this workflow in the Dev UI, it'll build the workflow and it can create a visualization of the workflow for me. So straight away I can see this is much more intuitive. I can see kind of like, how the different components in this workflow kind of relate to each other. So I'm going to configure and run this. Okay, so what I wanted to do is I wanted to plan a party for 50 people with a budget of $5,000. And I'm going to run the workflow. So you can see straight away I get a visualization. The coordinator took the request. It's passed it on to the venue agent. And I can see that the venue agent is working on this at the moment. It takes a couple of minutes for this to run. So I have a version of it that's completed. And I'm just going to talk about some other aspects of the Dev UI. So you can see here, everything is completed. I have a visualization. Everything is marked as green. there's a timeline of execution. So I can see that it started with the event coordinator. That took the original request. Then it passed it on to the venue agent. The venue agent then produced some output, right? So the venue agent actually needed to know where I want this event to be planned. So if I come back over here, you can see this is the human in the loop interaction that I'm having with this workflow. So the prompt here is asking me a city or a neighborhood for the event. So I'm just going to type in Seattle. And then it'll continue now. It'll pass on that additional information to the venue agent, and the venue agent can continue with its work. So I can see the entire workflow or timeline for the workflow. It goes back and forth between the different agents and the event coordinator. The other thing I can see is also the traces associated with this. So these are open telemetry traces. And I can see kind of like different aspects of what's going on within this workflow. So there's an executor process that's part of the workflow execution. In this particular case, what it's doing is it's invoking an agent. Here the telemetry is it's the Open Telemetry Gen AI standard. That's the convention that we're adhering to. So we're calling the event coordinator agent. It in turn is calling an LLM, and it's using GPT-5 Mini. I can drill into this and I can see the details of what that specific agent is sending to the model. The other things I can do in DevUI is I can also kind of like see any tools that were executed by the agents. So these agents are using kind of web search. So there's a web search tool call here. It's sending a request to identify venues in Seattle, and then I can see the responses that kind of came back from the web search. So I can not only visualize my entire workflow, I can also interact with the individual agents, right? So all of the agents that make up this workflow are listed here. I can bring these up and I get a basic chat interface and I can interact with those agents. So I can stabilize each part of my workflow in isolation. I'm using this tooling. Okay, so once I have my workflow built and I'm happy, the next thing I need to start thinking about is deploying it. And when I go to deploy it, I want to make sure that it's secure. I want to make sure that no sensitive data, say my company has a policy where we don't want to send any sensitive data to a large language model. So there's multiple options for integrating data security and data governance with Agent Framework. But we have one solution that uses Microsoft Purview. So with Microsoft Purview, actually, let's take a look at the code first. So this is what you need to change in your code to use Microsoft Purview. Right? So Microsoft Purview is an offering that provides data governance and data security capabilities. So I'm creating Purview policy middleware that basically I'm going to inject into every agent I'm using in the workflow. So I create the middleware. All I'm doing is giving it an application name. This is the code to create my agent, and I can just provide whatever middleware I want. And that middleware, anytime this agent is executed, that middleware will also get triggered. So it'll be called before the agent is run, so it'll be able to look at what data is being sent to the agent, and it'll also get triggered after the agent has executed, so it can see the responses. So this gives it the ability then to kind of block certain requests if there is sensitive data being sent to an LLM. So operationally, what that looks like is I can go to the Purview Activity Explorer, and I can see all of the interactions with this particular agent, right? So if I click on one of the interactions here, I can see when it happened, who it's from, and basically what information they sent. So this is a fairly ordinary request, just looking for the capital of France. I can also see the response to that, what came back from the model. Now, there's a couple of interesting activities here related to sensitive information. If I open up one of those, I can see again, who sent the request, and I can see what type of sensitive information was included. So in this case, it was a credit card number or a social security number. I can go to the related AI interaction, and if I open that up, I can see the exact message that was sent to the model. So if I just scroll down here, when the message loads, you'll see that it includes a credit card number and also a social security number. So now I've got my workflow built, and I have kind of like my security concerns kind of like addressed. The next thing I want to start thinking about as I build this application is I want to put a user interface on top of the application. So there's two options. I'm going to go through these super fast. The first one is using OpenAI ChatKit. This gives you a set of components, basically reusable components, so you could embed a chat into any of your applications. There's also some back-end components so that you can kind of build your own server. In this case, our server is using Microsoft Agent Framework. If I send it a request, you can see I'm getting kind of like a normal text response back. I'm also getting this widget. The back-end calls a function, and that function returns all of the weather information as structured data. I can then convert that into a widget, send the widget to the UI, and the UI then can render it, right? Like, so this allows me to go beyond basic chat interfaces. There's another protocol called Agent UI protocol that we support as well. Again, here I get a basic chat interface. What's interesting, if I send it a standard request, I'm sending it a request and I'm sending it a tool. The agent is deciding to run that tool, and it's changing the background. So it's actually changing the UI of the application that the chat is embedded in. Another interesting example of this is you're having shared state between your agent on the back end and then the front end. So in this case, I've got some UI that can display recipes. If I ask the if I ask the agent for a recipe for coddle, so coddle, I'm Irish, and coddle is a traditional Irish recipe. It'll call the agent, get structured data back which describes that particular recipe, convert it into state, send the state to the client, and then the UI can update. I also kind of get a text response back, the normal text response you get. Okay, so that's me.
Great, thanks.
Okay.
Mark. That's
Okay.
great. I love to see live demos. Those are great to see. So we built our agent system. We've got it running. Now we got to host it somewhere. We got to deploy it somewhere. We got to manage it. We got to integrate it with our other systems. Let's switch over here, back to here. Let's bring Tina up. You want to come on up, and you can talk about how we can get our agent systems that we built in Agent Framework up into Foundry. Come on up.
Thanks, Shawn. You know, it's such an exciting time to be alive, where all of these software systems are starting to transform into being more and more autonomous, and we are evaluating really the potential and risks of all of these autonomous systems. And all of the use cases that are actually driving real value today involve a lot of customizability in code. And these pro-code agent frameworks make all of this easy with the built-in primitives and orchestration patterns that these support. But when you actually want to go and operationalize it and take your prototypes to production, that's where the challenge is. And that's the challenge that we're looking to solve with hosted agents in Foundry Agent Service. We're thrilled to be announcing this in preview, this Ignite. This will enable you to come deploy, manage, and operationalize your pro-code agents that you've built in custom code, and be able to use that with the rest of the platform services.
There's nothing up there, Tina. Let's get this. I'm gonna press forward there. That's what we like to see. Right?
Oh, OK. Yeah. Yeah. So this is going to enable you to deploy, manage, and operationalize your workflows. We're bringing this with first-class support for Microsoft Agent Framework in Python and C#, LangGraph in Python, and more frameworks to follow. You can also start ground up with your own custom code with Python and C# as well. Now, all of this runs on a serverless, secure, managed runtime, which auto-scales based on your usage. All of this runs in your own dedicated execution environment. Your context is managed using the Responses API, and you can essentially implement versions of your hosted agents for different configurations that you want to have and be able to manage them across the end-to-end life cycle of how you create them, how you update, start and stop, and perform different operations of your agents. And all of this comes with the integrated set of tooling that we have on Foundry. So you have to write less boilerplate code, less implementations in your code. So you don't have to implement your own MCP clients in the frameworks that you're writing. And essentially just configure these tools once on Foundry and be able to use the same connection that you have to these tools in your Foundry project and plug and play with the code that you're writing to be able to just use these tools across different agents on Foundry. All of this comes with the managed authentication as well, so you don't have to implement your authentication flows in the code. Now, observability and monitoring is supreme importance, and so you're going to have all of this in the OpenTelemetry semantic convention. So all your logs, metrics, and traces are going to show up in the application insights resource that's going to be associated with your Foundry project. So you can monitor your agent execution steps, the performance, your operational health of your agents, and be able to govern them from there. Now, talking about how you want to be able to make sure that the non-determinism of these agents as well as the quality is in check, you want to be able to run continuous evaluations on them, use synthetic data or use human evaluations, and be able to set guardrails on different risks and harms that could be output from these agents, and be able to have compliance checks against these guardrails that you're setting and be able to take operations for those compliance checks that have. And all of this can be done using the Foundry control plane that we've also announced at Ignite. Now, let's talk a bit about interoperability. All of these agents can be deployed with activity protocol support by the service, so you don't have to implement it. And once you have them up with the activity protocol support, you can have your SaaS-based agents in Copilot Studio invoke these Foundry-hosted agents as a part of your workflows. Now, you can also publish your hosted agents to M365, A365, and Teams, and be able to create digital workers across your organization. Now, all of this with the non-negotiables of the enterprise security and data sovereignty, where you want to have all of these agents run in your own private virtual network and be able to use your own resources in your own Azure subscription to be able to store the state of your agents as well. Now, let's dive right into the demo of how you would go ahead, start from your local development to actually go ahead and host this on Foundry. Now, what I have here is an agent framework code, which essentially is modularized. I have this piece of agent Azure OpenAI client executed here, implemented here, which is just my agent, and then it is associated with the tools object, which.
All right, Tina, this is twice I had to bail you out. You owe me lunch now.
Sorry about that. Yeah, let me start over. So starting over from local development, I have this agent framework code, which is essentially modularized. You're going to see this package here, which is the adapter package, which essentially does a couple of things for you to be able to make this deploy on Foundry. So this essentially implements all the translation classes for the framework that you're writing to the Responses API. So essentially, these are deployable on Foundry and integrated with the rest of the Foundry platform. These also implement the tools client libraries to be able to invoke your Foundry tools that have been configured on Foundry locally as well. And then for all the OpenTelemetry packages that you would need to essentially instrument your agent code, so you don't have to, all of this is embedded and imported when you import this package. Now, talking about the agent code in itself, it's modularized in a way that you have your Azure OpenAI chat client here, which is essentially declaring your instruction for your agent. And then I have these set of tools that I have on Foundry essentially connected, which this is a connection that I have created on Foundry, and I'm just going to reference that connection ID here. Let's go ahead and quickly see what that connection looks like on Foundry. This is the connection that I've created to a Hugging Face MCP server from the tools catalog. And that is the connection ID that I'm going to be referencing here as well. So I'm going to be plugging in my tools to the agent and wrapping my agent code with the adapter so I have it exposed to Responses API. Now I'm going to quickly go ahead and run this. And this should spin up a local HTTP server for me that I can go ahead and invoke and test my agent with. Let's see, it's going to take a while. All right, while this happens, let's see if you guys want to switch over to deploying to Foundry already? Okay. Okay, how about we speak about AZD? Okay, it's running now. It's all there. Okay, so you can see it's starting my agent server, and then it should spit out the localhost endpoint that I can invoke. So you can see now this is running on my localhost endpoint here, and now if I want to just go ahead and invoke this for me. What I'm trying to do here is list all the tools that are exposed by this Hugging Face MCP server and see if locally I'm able to call this connection that I created on Foundry. And so it should essentially list all the tools based on the token that I configured for my connection, which essentially is based on the set of permissions that I've given while I generated that token. Okay. Looks like a lot of tools being retrieved here. Okay, so this is done. So you can see that the list of tools are basically the set of operations that I can do with this MCP server. So now all of this works well locally, and now it's time for me to go ahead and deploy this on Foundry. And so for me to go ahead and deploy this to Foundry, we're going to be using the Azure Developer CLI. I want to get a quick show of hands for folks who are familiar with the Azure Developer CLI here. OK, quite a few of them. But for the folks who are not, it's essentially the open source tooling that we have, which simplifies the provisioning and management of Azure resources. It's essentially combining your infrastructure as code and your app development. So it can provision your resources, it can set up identity and your role-based access for the resources that you want to tie together. And all of this is done using a Bicep or Terraform, and then it can also deploy your code. So if you have a project which has an agent and a web app, and you ideally want to be having to deploy this in the same environment, and so we came up with a specifically specified agent extension, which is the Azure AI agent extension, to be able to deploy hosted agents as a part of your AZD deployment experience. And so before I get started, I'm going to first create a new directory to make sure all my files are clean. And now I'm going to first go ahead and download the AZD template for me, which essentially has everything that I need to be able to work with Foundry. So this is going to install all the infrastructure as code files for me right here on my local machine. I'm going to set a unique environment name here, demo. And usually when you're provisioning resources as a part of your AZD experience, it uses the environment name for you to like provision all of those. Use this for provisioning all of those resources with the name. So it doesn't have to prompt you for all of that again and again. So you can see a project is now initialized. The next step for you is to essentially tell AZD which is the environment you want to actually be able to initialize here. And so in this case, I have a project already in place which has everything that all the resources, all the connections that I have, and I want to be able to deploy this in the same project. But you could be wanting to do something from scratch. You could be having a project, having some of the resources in place, not having some of them, and wanting to provision them as well. And I'm going to be talking about how that experience is going to look like. But in the case you have a project already, you're going to be initializing that in the context of that project here by saying AZD AI agent init and giving your project's resource ID. And so you're going to see it's going to set a bunch of environment variables for me based on the project's resource ID here. So it's setting the resource group, it's setting the account name, and it's identifying that I have a connection to the container registry already here. And so now if you want to go check how this repo is looking here, right here. So like your infra folder is going to have all your biceps. Your Azure.YAML is essentially a declarative way of showing what your services are going to get deployed eventually. So you're going to see that this currently doesn't have any registration for an agent. And for that purpose, we're going to be now using the Azure AI agent extension to be able to initialize that agent's configuration, which essentially is the definition of how the tools, the models, the behavior of that agent. And that essentially is going to look something like this in this repo right here that I'm going to try and deploy. So you see that this is where I'm saying that this agent actually requires a GPT-5 model. So it's going to go check if the GPT-5 model is available in that project. And says it is, and then it's going to go ahead and ask me for a bunch of other compute information that I need to be able to deploy this agent. Then I'm going to go configure the min and max replicas that I need for this agent. And now my agent definition is registered as a part of this project. And I can go and check how this looks like and verify. You can see that this agent is now registered here. And so it has the context, the configuration of the agent that I actually want to go and deploy. And so it is now as simple as just saying AZD deploy for you to like push this to cloud. Now let's say you were doing this in a project where you didn't have some of the resources, like you didn't have an Azure Container Registry, or you didn't have your app insights configured. You would essentially have to do an AZD provision first before you run an AZD deploy. So you're going to see how this is packaging my code now. It is going to build that image for me. This is going to do a remote build. So this is building this image using ACR tasks. So you don't need to have Docker on your machine. And it's going to push that image on the ACR that is associated with my project and figure out the identity that my project needs to be able to pull that image and then go ahead and deploy. This is going to take a while. So I am going to switch over to Foundry UI, where I already have this agent in place. So you're going to be able to see all your hosted agents once they are created, along with the workflows and prompt agents that you have on Foundry here. And I'm going to go ahead and see if I can prompt this for, say, generate an anime like picture for a girl in the city using one of the Hugging Face spaces. Actually, I'm going to say using Quinn's Hugging Face spaces. And so what it's going to do is it's going to use the authorization that I have using that token to be able to generate that image on behalf of me. And while it does that, I want to walk you through some of the operations that you can do with this agent. So you're gonna be able to see the list of the details that you have for this agent on the left. So you can see the container image which is associated with that image with the agent here. You're going to be able to do a couple of operations like being able to stop your agent. So this is a force stop. You're going to be able to delete your agent deployment if you want to deprovision your resources. You can see I have 2 versions of this hosted agent, so you can also go here and compare the 2 versions and be able to see how the 2 versions are able to perform for the same prompt, for example. And let's say I have this V1 of this agent, which is essentially stopped right now. So you can go ahead and click start here to start it in a couple of seconds right here, all from Foundry UI. If you want to invoke this using code, you can just go here and click here for provisioning your VS Code in web, which essentially installs all the dependencies, has the setup in place for you to essentially just run the script and invoke it. You can see this is actually finished processing, so this has returned this image. Very good, I would say.
Nice. So, thank you, Tina. What I love about what we're able to show here is that we've been able to show you how you can take your code in your environment in Visual Studio Code and deploy it into Foundry. You can try this out today. Build your agents, build your agent systems, get them deployed into Foundry, and use them just like your agents that you've built directly in Foundry. So something you can try today. Give it a try, and we'll make that available with pricing pricing details in February. Okay, so we talked about some great things we can do about using Microsoft Agent Framework, using MCP and A2A, multi-agent workflows, telemetry, Purview, hosted agents, and then UI with ChatKit and AGUI. So we have some great solutions for all the things that you're seeing when you're building your agents and deploying them into Foundry. Some quick notes. Let's just move ahead. I think we're almost out of time. If you want to find out more, go to ai.azure.com. You can try out our new portal. If you want to try the Microsoft Agent Framework, aka.ms Agent Framework, go to GitHub, search for Microsoft Agent Framework. You can find it there. A bunch more sessions that you can go and check out. And then I believe also Mark is running a lab this afternoon over in Moscone West. There might be a couple seats left where you can go and try out Microsoft Agent Framework for yourself. Thank you everyone for your time. We'll be hanging out at the booth after this, and I have some stickers if folks want to come up. If you'd like some swag, I mean, come up and say hi. Thank you, everyone.